Yeah. Hello viewers, welcome to my YouTube channel, Mathematics Medicine. So in today's video, I'm going to take from where we stopped in our last class, calculus. So in my previous video, I already talked about the quotient rule, the product rule, the chain rule. All right. So in today's video, we are going to talk about the quotient rule. The quotient rule. All right. So when you're talking about the quotient rule, it means when your function is in form of what? Fraction. So how are you going to differentiate that kind of function? Okay. So if your function is in this form, if you have y is equal to p of x over q of x. Now look at that function. So if your function is in this form, all right, so you have to differentiate that function. So what method are you going to use to differentiate that? So that is when your quotient rule will come in. All together now, then you can now make some substitution. So you said let's u of x be equal to p of x. All right, the function on the numerator, and then you said let the v of x be equal to q of x. That's the function in the denominator. Then you differentiate with respect to x. So you have du of x over dx. So if you differentiate this, you are going to get what? P prime of x. Alright? And then the v of x over dx. If you differentiate this will give you what? Q prime of x. And then here is the quotient rule. So the quotient rule says that dy over dx is equal to what? V the u dx, okay, minus u the v over the x. Then everything over v raised to the power of 2. Are we together now? So where your v is q of x, okay, then your du dx is what? P of x. So p of x, okay, then minus u, which is what? P of x multiplied by the v dx, which is what? Q prime of x, and everything over what? V squared. That is q of x, then everything squared. Do you understand now? So that is your what? That is your quotient rule. So that is your quotient rule. All right. Now let's do some examples on the quotient rule. Don't forget, as you are watching, please don't forget to subscribe. Okay. Don't forget to like. Don't forget to comment, and don't forget to share. And then you click the notification button so that anytime I upload video, you'll be the first to watch. All right, now let's do some examples related to this method. Example 1. So we have y is equal to sine x over cos x. All right, y is equal to sine x over cos x. Then find the y over the x. Find the y over the x. Though we already know that sine x over cos x is what? Tan x. Do you understand now? So we already know that sine x over cos x is tan x. But I want to make use of quotient rule to differentiate this particular function right here. Alright, so that's why I write the tan x in what? In fraction form like this. Okay, now let's do that together. The first thing, don't forget, I said that you make your substitution. You say let u of x be equal to sine x, and let v of x be equal to what? Cos x. Alright? The function in the numerator, that will be your u of x, and the function in the denominator, that will be your v of x. Then the next thing we are going to do is differentiate. So the u dx will give us what? If we differentiate sine x, that will give us what? Cos x. And then the v dx, if we differentiate cos x, that will give us what? Minus sine x. Alright? That's good. Then next thing we are going to do is what? Is to apply the formula. And then what's the formula? So we know that dy over dx is equal to what? V the u dx, okay, minus u the v dx, then everything over what? V raised to the power of 2. So what is our v? That is cos x. So we have cos x, then multiply by what's your du dx? We have cos x, okay, multiply by cos x, then minus u. So what is our u? That is sine x. Then what is our dv dx? That is what? Negative sine x. Then everything over what? v squared. So your v is what? Cos x. So everything over cos x, then raised to the power of 2. Alright? So minus times minus will give us what? Plus. So let me continue it here. So minus times minus will give us plus. So cos x times cos x will give us what? Cos squared x. Then we have plus sin x times sin x, sin square x, then everything over what? Cos square x. Alright. So remember from our trigonometry identity, so we know that cos square x plus sin square x will give us what? 1. So instead of us writing cos square x plus sin square x, we are going to write 1. So we have 1 over cos square x. Okay? And then also, you remember that 1 over cos x is equal to what? Remind me, is equal to sec x, alright? So definitely 1 over cos square x will give us what? Sec square x. So therefore, dy dx of this function is what? Sec square x. And definitely dy dx of tan x is also what? Sec square x. Are we together now? So we write tan x in form of fraction, we have sin x over cos x. And then when you differentiate it, we have what? The derivative of what? Tan x, which is sec square x. I hope it's clear. I hope it's clear. So are we together now? All right, guys. So now let's move on to the next example. All right. So we have another example that I want to solve. Okay. Now let's move on to the next example. Example number 2. So don't forget, as you are watching, don't forget to subscribe. Don't forget to like. Don't forget to comment. And don't forget to share. Okay, so example number 2. So we have this function, we have y is equal to exponential x over, let's just use sine x, okay, plus cos x. So find dy over dx. Alright, so that's the next question. We have y is equal to exponential x over sine x plus cos x. So I want to find the derivative of this particular function right here. So how do we find the derivative? All right. So we are going to make use of what? Your quotient rule. Since we are having a what? A fraction. Since a fraction. Okay. So the best method to make use of what is what? Your quotient rule. All right, guys. So now let's dive in. It's the solution. Solution. Don't forget, I said the first thing I'm going to do is what? Is make use of your substitution. It said let u be equal to the function of the numerator, which is e raised to the power of x, and let b be equal to the function at the denominator, which is what? Sin x plus cos x. Alright? So the next thing you are going to do now is what? To differentiate here with respect to x. So if you differentiate exponential x, in my previous video, I already talked about this. We differentiate your exponential x, you are going to get exponential x. Are we together now? And then if you integrate it, it's still the same thing. You are going to get exponential x. So it's not changing. Alright? The derivative and the integral is what? The same. So the u dx is still what? Exponential x. Good. Then differentiate this one also. So the v over the x will give us what? If you differentiate sin x, don't forget you are going to get cos x. And then if you differentiate cos x, you are going to get negative sin x. Alright? So we have derivative of sin x plus cos x is what? Cos x minus sin x. Okay? Then you mix up your formula, which says the y over dx is equal to what? V then dx, okay? Minus u then v dx, okay? Then everything over v raised to the power of 2. So what is our v? Our v is what? Sin x, okay? Plus cos x. Then multiply by the u dx, which is exponential x. Alright? Then minus u, so your u is exponential x. Then into bracket the v dx, which is what? Cos x, then minus sin x. Then everything over square of v, that is sin x plus cos x, then raised to the power of 2. So this is beautiful. So let's move on here. Let's move on here. So we are going to expand this, right? So exponential x is common throughout, so we can actually factor out exponential x. So if I do that, I'm going to have exponential x, then into brackets. So what I'm going to have here will be sin x, okay, plus cos x. And what I'm going to have here is what? I have to expand this by this negative sign. So negative times cos x, we have negative cos x, right? The negative times negative is plus, so we have plus sine x, all right? Then everything over, all right, sine x plus cos x to the second power. Okay guys, so we are going to have exponential x into bracket, cos x minus cos x will give us 0, and sin x plus sin x will give us 2 sin x. Then everything over what? So if you expand sin x plus cos x, what are we going to have? Let's do the expansion here together, alright? So sin x plus cos x multiplied by sin x plus cos x. So what is this going to give us? Sin x times sin x will give us sin square x. Sin x times cos x will give us sin x cos x, okay? So cos x times sin x will give us what? So sin x cos x, and then cos x times cos x will give us what? Cos square x, alright? So you are going to have sin square x, okay? Plus cos square x, okay? Plus sin x cos x plus sin x cos x, 2 sin x cos x. Alright? Then remember that sin square x plus cos square x is what? 1. Alright? So you are going to have, instead of us writing sin x plus cos x to the second power, so I can write 1 plus 2 sin x cos x. Are we together? And then if you remember, I think 1 plus 2 sin x cos x should give us, I think should give us sin 2x, if I'm not mistaken. Yeah, this should give us sin 2x. Because from your trig identity, yeah, this should give you sin 2x. Okay, so we are going to have exponential x. So you can bring out these two. So 2 multiplied by exponential x multiplied by sin x, then over sin 2x. So that is the answer to that beautiful problem. You can see that this is very nice and beautiful. All right. Okay. So now let's move on to the next question. Don't forget to like, don't forget to comment, don't forget to share, don't forget to subscribe. All right. Okay. So let's do another question. Yeah, question number 3. We are still on differentiation, all right? Differential calculus. So once we are done with differential calculus, okay, so we can deal with some limit problem, and then we deal with integral, both the indefinite integral and definite integral, all right? So watch out for that. So the first question we are going to be doing now, so we have y equal to, all right, the sine exponential x, then over natural log of sine x. So you have to find the y dx. So find the y dx. Now look at this problem. You can give it a try. All right, give it a try. You have y is equal to sine exponential x over natural log of sine x, and then you want to find the derivative. Okay, can you solve the problem? Right. So we cannot solve the problem now. Let's solve the problem together. Are we ready? Let's count 1 to 3. 1, 2, 3. Good. Now you can see this function right here. It consists of your composite function, and then we have the natural log of sine x here. So what are we going to do to actually solve this problem? Good. So the first thing is to make your u. So u is the numerator. So we have u is equal to sine exponential x, all right? And then we have v is equal to what? Natural log of sine x. Now, this is a composite function like your composite method, which is a chain rule, all right? So we're going to make the chain rule to find the derivative of sine exponential x. And then also here, we're going to use the chain rule to find the derivative of natural log of sine x. Are we together now? And then my previous video, I already talked about the chain rule, the product rule, all right? I already talked about it. So now, and then the first principle too. So I'm going to find the derivative of sine exponential x, and then I'm going to find the derivative of natural log of sine x. Now let's dive in. Now, look at this. We have u equal to sine exponential x. Then the first thing you are going to do is you making a substitution. And then if you already know how to do it straightforward, let's solve this without you making any funny substitution here. Do you understand what I'm saying? Like, let's do that together. This one mean, so we can now say that du dx is equal to what? D dx, okay, of exponential x. Then multiply by, when you make exponential x, sorry, from when you say let exponential x be u, so multiply by d du of what? Of sine u. You actually understand what I'm saying? Like your du dx, okay, sorry, yeah, du, or let's just say du the lambda right here. Because, okay, let's make exponential x lambda, right? So we have the lambda. That's actually beautiful. Are we together now? So, the first thing is to differentiate exponential x. Then, if we differentiate exponential x, let me put lambda here. So this will give us exponential x. And then if we differentiate sine lambda, so that's going to give you what? Cos lambda, right? Multiply by cos lambda. And what's your lambda? Exponential x. Alright? So the u dx is what? Exponential x multiplied by cos e raised to the power of x. I hope it's clear. Next thing, you can do the same thing for this one. So we have the v over dx is equal to what? So you find the derivative of sine x. So we have d dx of sine x, okay? Then multiply by, so I can say that, okay, let my sine x be lambda, right? So I'm going to have d the lambda of what? Natural log of what? Lambda, since my sine x is now lambda, alright? And then, don't forget, if you differentiate natural log of lambda, what are you going to get? That will be 1 over lambda, alright? I already told you in my previous video. So d dx of sine x will give us what? Cos x. Then d the lambda of natural log of lambda is what? 1 over lambda, alright? So where your lambda is what? Sine x. So we have 1 over sine x. So which is equal to cos x over sine x. And remember, cos x over sine x will give us what? Cos x. Cos x, right? So definitely that shows that if we differentiate natural log of sine x, that's going to give you what? Cos x. That's beautiful. So we can now base of our quotient rule. So which says that, alright, the y over dx is equal to what? V the u dx, okay, minus u the v dx, alright, then everything over v raised to the power of 2. So then this will give us v, which is natural log of sine x, okay, then the u dx, which is what? Exponential x, then multiply by cos exponential x. So minus u, and then our u is sine exponential x, okay, then multiply by the v dx, which is what? Cos x. Then everything over v raised to the power of 2, that is natural log of sine x to the second power, alright? To the second power. So let's just put it square here. So this is actually beautiful and nice, okay? So finally, we have our answer. So I can factor out this exponentially right here. So I have exponential x, natural log of sine x, multiplied by cos exponential x, and minus by cos that x, then everything over natural log of square of sine x. So can we see that this is actually beautiful and nice? All right. So that is that about that one. All right, guys. So don't forget, as you're watching, don't forget to subscribe. As you're watching, don't forget to like. As you're watching, don't forget to share this video. So let it go viral. Let people see it. Let people also. Are we together now? Good. So that is the answer to that particular problem. Okay. So that's how you can differentiate such a function. Are we together? All right now. So let's check another function right here. All right, guys. Now, here's another question. So we have y is equal to 1 minus x over 1 plus x. So we have to find the derivative find the y over the x. Look at that function. We have y is equal to 1 minus x over 1 plus x, then find the derivative. Okay, find the y dx. So how do you now find the y dx in this particular question? Answer me, everybody. So we are going to make use of what? What method? Your quotient rule. You're going to make use of your quotient rule. I'm coming. All right. Okay, now let's move on. We are going to make use of our quotient rule to actually find this derivative of this particular function. All right, so as you usually do, you make use of your substitution. You said, let u be equal to 1 minus x, and let v be equal to 1 plus x. Are we together? Then you find the u dx. So the u over dx, so don't forget, if you differentiate minus x, so this will give us negative 1, all right? Because if you differentiate to 1, that is 0, and if you differentiate negative 1. Then the v dx will be equal to what? 1. If you differentiate 1, you get 0, and if you differentiate x, you get 1. That is cool. All right, that's cool. So what are we going to do next? You mix up your formula, all right? So which is the y dx is equal to v the u dx, then minus u the v dx, then everything over v to the second power. Are we together? So v is 1 plus x, so we have 1 plus x, and the u dx is negative 1, then minus u, which is 1 minus x, and the v dx is what? Positive 1. Then everything over v to the second power, so which is 1 plus x to the second power. All right, so then this will give us, if we open the bracket with this negative 1, so negative 1 times 1 will give us negative 1 times x will give us negative x. Now, negative 1 times 1 will also give us negative 1. Negative 1 times negative x will give us positive x. And everything over 1 plus x to the second power. So this will surely give us what? Negative x plus x will give us 0. And negative 1 will give us what? Negative 2. So you have negative 2 over 1 plus x to the second power. Alright, so that's the answer to that question. So if we find the derivative, of 1 minus x over 1 plus x, so we have what? Negative 2 over 1 plus x to the second power. Alright guys, that is that about this third question. Now, let's talk about another question. Now, so let's say we have y is equal to x to the x power, okay, then over natural log of x. So find the y over dx. So he has to find the derivative here. Look at that question carefully. You have y is equal to x to the the power of x, then everything over natural log of x. So we have to find the y dx. So how do we find the derivative right here? Now look at it. This question is actually, it's look nice, isn't it? Very nice question. Okay, now let's do that together. So we said, let u be equal to x raised to the power of x. And let v be equal to natural log of x. Are we together? Now, this is a function in form of fraction. So definitely as a quotient rule we are going to make use of. Alright? And then for us to make use of our quotient rule, we must know the derivative of x raised to the power of x. That is very, very, it looks somehow. Then if you check my previous video, I already solved this. So I already find the derivative of x raised to the power of x in my previous video. But I'm still going to do it now, alright? So that you guys can actually follow and then understand it very well. Alright, now let's do that together. So we have u is equal to x raised to the power of x. So how are we going to find the derivative of this particular function? So what are we going to do? You know, if you are the kind of person that follow me very well, so the first thing you are going to do is what? You take the natural log of both sides. So if you do that, we have natural log of b is equal to natural log of x raised to the power of x. Alright, then according to law of logarithm, you know, if you have natural log of a raised to the power of b, so this will surely give us what? B multiplied by natural log of a. So that is, we are going to bring out this what? This x. Are we together? Then we do that, we are going to have natural log of u is equal to x multiplied by natural log of x. Now, if we find the derivative of natural log of u, what are we going to have? We are going to have 1 over u, then du. Then you can see that this part is in form of what? Products. You know, products rule. So that's what we're going to make use of. X is multiplying another function, natural log of x. So the first thing is to find the derivative of x. Okay, so we have derivative of x. Then the answer that you got multiplied by natural log of x. So plus, you know, x multiplied by the derivative of natural log of x. Are we together, guys? So now, if you are doing that, we have 1 over u, then u, so which is now equal to, you know, if you find the derivative of x, you are going to get 1, and 1 multiplied by natural log of x will give us natural log of x. Then plus x multiplied by, if you find the derivative of natural log of x, we have 1 over x. So definitely, x will come out x here, okay? So what you have now, don't forget, you have to put the x here. So we have 1 over u, the u is equal to what? Natural log of x plus 1 dx. So we can actually multiply both sides by u and divide through by dx. So we have du dx is equal to what? U multiplied by natural log of x plus 1. And remember, u is x raised to the power of x. So we have x raised to the power of x into bracket natural log of x plus 1. So you find the u dx, we have this. Now let's find the v dx. So the v dx will be equal to what? If we find the derivative of natural log of x, so that will surely give us 1 over x. Then you use our formula, which is what? The y over dx is equal to v du dx, then minus u dv dx, then everything over v raised to the power of 2. Then this will give us, you know, v is what? Natural log of x. Then du dx is what? This guy right here. X raised to the power of x multiplied by natural log of x, then plus 1. Then minus u, which is x raised to the power of x, then multiplied by the v dx. What's our dv dx? That is 1 over x. Then everything over v squared. That is square of natural log of x. So x raised to the power of x multiplied by 1 over x. You know, you can raise up your law of units right here. You know, 1 over x can be written as what? X raised to the power of minus 1. Okay? Then x raised to the power of x multiplied by x raised to the power of minus 1 equals what? X raised to the power of x minus 1. The law of indices. Right? So that shows that x raised to the power of x multiplied by 1 over x is what? X raised to the power of x minus 1. Are we together? So therefore, this gives us natural log of x, then into bracket x raised to the power of x multiplied by natural log of x plus 1, then minus x raised to the power of x minus 1, then everything over natural log of square x. Very beautiful. Very beautiful. All right. So that is the answer to that what? To that particular question. I hope you are getting it, guys. Okay, now let's do 4 more questions. Then after the 4 questions, I'm gonna end the live for today. Okay. So let's do 4 more questions. I hope we are getting it. Now, look at this. We have y is equal to arctangent of sine x over natural log of, give me one function there, e raised to the power of x squared plus 2x plus 1. So find the derivative. Look at that. You have y is equal to arctangent of sine x, then over natural log of exponential x squared plus 2x plus 1. So we want to find the derivative. Yeah, if you are a teacher, okay, if you are a calculus teacher, you can actually like give your student this kind of test here to test their understanding about this particular topic. And if you are a student, yeah, this is also for you. All right. So make sure you read beyond the scope of the class. All right. Just take any question, make sure you try them, and then you become an expert. Yeah, that's how you become an expert. All right. So that's how I train myself also. Okay, guys. Now to not waste much of our time, let's find the derivative of this function right here. Now let's get started. All right. So the first thing we are going to do now, okay, is your substitution. All right. Okay. So we have let u be equal to the function at the numerator, which is arc tangent of sin x, and then the function at the numerator b of b, natural log of exponential x squared plus 2x plus 1. All right. Now the first thing is to find the derivative of this right here. And I told you in shortcut you are going to make use of. You want to find the derivative of this kind of function. Okay. So I said the u dx will be equal to what? The derivative of this sin x, that is d dx of sin x, then multiply by what's it called? Arc tangent of sin x. The derivative of arc tangent of x. So if I call this sin x, if I call it lambda, so it means multiply by d the lambda, right? Of what? Arc tangent of lambda. Are we together now? So if I differentiate sin x, I'm going to get what? I'm going to get cos x. Okay. Then multiply by, if I differentiate arc tangent of the function. So arc tangent of lambda, we are going to have 1 over lambda squared plus 1. But in this case, we already know the value of our lambda, which is sin x. So definitely, we are going to have what? Arc tangent. 1 over lambda squared plus 1. So now it becomes 1 over what? Sin square x plus 1. Are we together? But remember that, cos square x plus sin square x is equal to 1. So we make sin square x the subject formula. You can have sin square x is equal to 1 minus cos square x. Okay? You can actually put your sin square x to be what? 1 minus cos square x. Anyhow. Or you input 1 to be what? Cos square x plus sin square x. Anyhow like that. But let's just leave the problem this way. So let's leave it like that. So alright, now let's move on. So we are gonna have cos x over sin square x plus 1. So if we differentiate arc tangent of sin x, we are going to have cos x over sin square x plus 1. Now, the second function right here, so which is b is equal to natural log of exponential x squared plus 2x plus 1. Okay, so how do we find the derivative? Now, this is what we are going to do. So we say the v dx is equal to what? Is equal to d dx of this function inside the bracket, which is exponential x squared plus 2x plus 1. Then multiply by what? The derivative of what? Natural log of lambda, because I've got this lambda. So multiply by d lambda of what? Natural log of lambda. Now, this is where another problem comes. Now, you look at this, you have exponential x squared plus 2x plus 1. So how can we find the derivative of this? Alright, so for you to be able to find the derivative of this, you are still going to make use of what? Another chain rule. Okay, so d dx will now be equal to what? You differentiate x squared plus 2x plus 1. So if you differentiate x squared plus 2x plus 1, what are you going to get? You get 2x plus 2. Then multiply by what? The derivative of e exponential, anything you like, you are still going to get what? Exponential of that function, right? So the derivative is not changing. Okay, so you're going to have exponential x squared plus 2x plus 1. So that's the derivative of this guy. So let me just change it to the y, the u, yes. Then if you differentiate natural log of lambda, so you are going to get what? 1 over lambda, alright? And then don't forget, lambda is what? lambda is exponential x squared plus 2x plus 1. So we have 1 over exponential x squared plus 2x plus 1. Alright, so this is exponential x squared plus 2x plus 1. This is also exponential x squared plus 2x plus 1. So definitely, this and this will cancel out. So we have 2x plus 2. Even this is actually beautiful. We don't even need to like undergo this all the stress. Yeah, this just comes to my mind. You know, we have natural log of exponential x squared plus 2x plus 1. So you can do it this way. According to the law of logarithm, we have natural log of a raised to the power of b. This will give us b multiplied by natural log of a. Alright? So you just bring your x squared plus 2x plus 1 here. So you're going to have x squared plus 2x plus 1, then multiplied by natural log of e. I remember natural log of e will give us 1. Okay? So you're going to have x squared plus 2x plus 1. So that's everything here. You just find the derivative, you get what? 2x plus 2. Say clock it. Alright guys, now let's move on. So we get 2x plus 2 as the derivative of natural log of, you know, e raised to the power of x squared plus 2x plus 1. Now let's make our formula to find the final derivative. Alright, now to find the final derivative, we know that dy dx is equal to v du dx, okay, then minus u dv dx, okay, then everything over v to the second power. So what is our v? So our v is this guy, so which is also x squared plus 2x plus 1. Don't forget, we already say that this is simplified into x squared plus 2x plus 1. Alright, so we're gonna have x squared plus 2x plus 1, then multiplied by du dx. So what is our du dx? Our du dx is cos x over sine square x plus 1. Then minus, what is our u? Our u is arctangent of sine x. Okay, then multiply by dv dx, so which is 2x plus 2. So multiply by 2x plus 2. Then don't forget everything over v squared. That is everything over x to the second power plus 2x plus 1, then everything to the second power. So let's just simplify this completely and let me write the final answer somewhere here. Oh my goodness. Alright, so let me write the final answer here. So I'm going to have the y over the x is equal to x to the second power plus 2x plus 1, then multiply by cos x. Okay, so over sine square x plus 1, then minus arctangent of sine x, then multiply by what? 2x plus 2 over 1. Then everything over x to the second power plus 2x plus 1, then everything to the second power. Alright, so you can actually, find the LCM here. So if you find the LCM is what? Sine square x plus 1. So therefore this will be equal to x to the second power plus 2x plus 1, right? Multiply by cos x. Then minus, this is over 1. So this sine square x plus 1, we multiply everything here. So 2x plus 2. Multiply by sine square x plus 1, then multiply by arctangent of sine x, alright? Then everything over what? So sine x square x plus 1, we multiply everything here. So we have sine square x plus 1, then multiply by x to the second power plus 2x plus 1, then everything goes to the second power. Alright guys, so that is actually beautiful and nice. So that will be the answer to that problem. So that shows that if you differentiate or you find the derivative of arctangent of sine x over natural log of exponential x squared plus 2x plus 1. So we're going to get this answer. Okay, so I hope we are getting it, guys. So that's actually good. That's nice. Now let's do the last problem for today. Then we end the lab. So last question on quotient rule. Quotient rule. Now, here's your question. We have y is equal to square root x squared plus 2 over, let's use a trig function, over sine, cos, tan, x. Yeah, this is the last question for today, so it has to be very hard. Do you understand? So we must solve a hard question. So look at the question. we have y is equal to square root x squared plus 2, then over sine cos tan x. So how do we find the derivative of this particular function right here? Okay, so let me write the equation so I have enough space to do my work. So I have y is equal to square root of x squared plus 2, and everything over sine cos tan x. Yeah, this is actually beautiful. So you can try the question. Yeah, you know, as a calculus teacher, if you look at this question, yeah, you can actually give one of your students a try. You know, to just test their brain. Yeah, this question is somehow, but yeah, we're gonna solve it together now. So that if you come across this kind of question later on, you'll be able to solve it. Okay, now the first thing you're going to do is your substitution. Say you put u to be, you know, square root of x to the second power plus 2, and then v is equal to sine cos 10x. Yeah, that's good. So what are we going to do now? How are we going to differentiate u is equal to square root of x squared plus 2? So how are we going to do that? Look at that here. Look at that. So the first thing we're going to make use of, like, you do another substitution right here. So we do the substitution. So I can say let's lambda be equal to square root of x squared plus 2. All right. So if lambda is equal to square root of x squared plus 2, and then if we don't want to do that, you can actually do it this way. Just square the both sides first. So we square the both sides to eradicate the square root. So square root cancel the square root here. So I'm going to have u to the second power is equal to square root of s squared plus 2. Alright? I can also make the square root here. Alright? So square root, you take the square, you take the square. So square root cancel square root. Alright? So I'm going to have u raised to the power of 4 is equal to x to the second power plus 2. So we cannot differentiate. So if we differentiate u raised to the power of 4, we have 4u raised to the power of 3, the u. Then if we differentiate x squared plus 2, we're going to have 2x and dx. Alright? So we're going to have the u over the x is equal to what? That is, if we differentiate through by dx, and then you're going to divide through by dx, and you're going to divide through by 4u cubed also. So we have 2x over 4u cubed. But remember that u is what? This guy, root x squared plus 2. So this will be equal to 4x over 4, then roots x squared plus 2, then everything raised to the power of 3. Alright? Everything raised to the power of 3. And then this can also be written as what? 4, you cancel out 4 here. Hey, sorry, this is 2. This is 2, so take note of that. This is 2. So 2 into 1, 2 into 4, that's 2. So I'm going to have 1 over 2, then multiply by x, then everything over. This is cube. So if I say u cube, it means what? U squared times u, alright? And then I'm going to have square root of s squared plus 2, then square, then multiply by square root of s squared plus 2. All together. So square will cancel what? The square root. So what I'm going to have will be what? Square root of what? S squared plus 2, then multiply by square root of s squared plus 2. Do you understand now? So that will be my what? This guy right here. So I'm going to have square root of s squared plus 2, then multiply by square root of s squared plus 2. Now, I think we can still simplify this further. Can we still simplify this further? Remember, this is square root of s squared plus 2 can also be written as square root of s squared plus 2, then raised to the power of 1 over 2. Alright? Law of indices. So, since we have this, so I can now rewrite this as square root of s squared plus 2, then multiply by square root of s squared plus 2, then raised to the power of 1 over 2. And this is also what? S squared plus 2. Let's just write square root here. Alright? So this is square root raised to the power 1, this is square root raised to the power half. So according to law of indices, we can add the exponents. So we're going to have square root of s squared plus 2, the raised to the power of 1 plus 1 over 2. And that will give us what? we're going to have square root of s squared plus 2, then raised to the power of what? 3 over 2. All right. So that's what we're going to have. So if you simplify that completely, we have 1 over 2 into bracket x over what? Square root of s squared plus 2, then raised to the power of 3 over 2. All right, so that is our du over dx. Now, let's find the v over dx. So let's do that together. So find the v over dx, v is sine cos x tan x. So therefore, dv over dx will be equal to what? So the first thing is to find the derivative of d dx of cos tan x, okay? Then multiply by the derivative of sine lambda, which is what? Cos lambda. So which is cos lambda. And then our lambda is what? Cos tan x. That is beautiful. So the next thing is to differentiate this guy. So, and this will give us what? If you differentiate sin x, you are going to get what? Sec square x. And then if you differentiate cos x, you are going to get what? Negative sin x. So that will give us negative sin x. And then our x here is what? Tan x. Alright. Then everything multiplied cos tan x. So we can actually bring this negative sign out. So if we do that, we're going to have negative sec square x sine tan x. Okay, then multiply by cos into bracket tan x. Alright. So that's our what? dv dx. So then you make use of your formula, which is what? dy over dx is equal to v du dx, okay, minus u dv dx, okay, then everything over v raised to the power of 2. Right, so let me clean these parts. Alright, so we can now have dy over dx, so which is now equal to v. So what is our v? So that is square root of s squared plus 2. We can also rewrite this now. Yeah, let's do that. Let's rewrite. So this means square root of s squared plus 2 means square root of s squared plus 2 raised to the power of half. So let me just write square root of s squared plus 2 raised to the power of half as my v. As my u. Okay, so that's my u. But my v is this guy. So v is sine cos tan of x. Okay, then multiply by du dx. So what is our du dx? This guy right here. So multiply by 1 over 2. Just do this. Multiply by 1 over 2, alright, into bracket x over square root of s squared plus 2, then raised to the power of 3 over 2. Okay, then minus u dv dx. So what is our u? So let's do this. So our u is x squared plus 2, then raised to the power of 1 over 2. So multiply by dv dx. What's our dv dx? So this is our dv dx, which is negative sec square x multiply by sine tan x, okay, cos tan x. Alright, then everything over v, that is, we have sine of cos of tan x. You can see that the answer is very long. Very, very long. So minus and minus will give us, we're going to have sine cos of tan x. So we can bring out this 1 over 2. So we have 1 over 2 multiplied by this. So let me just put the x also here. So x over 2 multiplied by sine. Then multiply by 1 over square root of s squared plus 2 raised to the power of 3 over 2. Minus times minus will give us plus. So we have plus sec square x multiplied by sine. We are multiplied by cos tan x. Alright. Then everything over v raised to the power of 2, which is sine cos tan x. Then raised to the power of 2. So that is the answer to that beautiful question. Alright. Oh, we forgot to put this guy. Sorry. So we forgot to put that guy. So if you put the guy here, let's just put it here. So no space here. Alright guys, so that's the answer to that question. So if you like this kind of video, please don't forget to subscribe to my channel. Alright. Comment, like, and share. Thanks for watching. See you next time. Bye.